Hi, welcome to section B for chapter 3, a little bit of a shorter section today. We're going to continue talking about atoms within matter. Make sure you're following along in the book as we go though, okay? All right, so let's talk about the different pieces that actually make up the atom. Remember we talked about the fact that the atom can actually be broken into its parts. These are some of the basic parts. There's additional parts, but we're not going to get into those. All right, so first we have electrons. Electrons are negatively charged. Those are the little red dots you see over there. And they fly around the outside of the atom, okay? They're virtually weightless, and they're kind of in this empty space around the nucleus themselves. To kind of counteract that negative charge, we've got protons, which are positively charged, found in the nucleus, the center part of the atom right here. So this would be considered the nucleus. Those green balls with the little pluses on them, those are the protons. They're positively charged. Now, a lot of the weight of the atom comes from the nucleus, okay? The proton weighs 1,836 times more than an electron, okay? Then that leaves us with the blue dots there in the middle. Those are the neutrons. They do not have any charge to them. They are not positive or negative. And they weigh very close to the weight of a proton. They are 1,838 times heavier than an electron. Okay, so very close to the proton. Now, typically, the protons and the neutrons are kind of close in number. We'll talk about some differences on the next slide. In a non-charged atom, the number of electrons equals the number of protons because the positive and the negative balances out, okay? So those are the basic parts there. Let's keep talking about the properties of an atom, and you'll see several of these properties on a periodic table, okay? If you look at any periodic table, you'll see these little boxes with numbers on them. We'll talk more about this, but I'm going to show you what some of those numbers mean right now, okay? First, and probably the most important thing on a periodic table is the atomic number. It helps you find things on the table, okay? If we actually go back, let me go back to this slide right here. I want you to count the green balls in the middle there, and you can see that there's 6, okay? Well, that's the atomic number of carbon. There are 6 protons, and so if you look on a periodic table, the number for carbon is 6. If you look at oxygen, the number is 8. That tells you that there are 8 protons in an atom of oxygen, okay? Again, if it's a neutral sample, then the number of protons will equal the number of electrons. We'll talk about when that's different, okay? Isotopes are atoms with different numbers of neutrons, okay? Oftentimes you'll get an atom where the number of protons is equal to the number of neutrons. And that's why, so if you see this atomic mass down there, I'll talk about that in a second, it's almost 16, okay? Well, if I double the atomic number, that gives me 16. Remember, the neutrons and the protons weigh just about the same amount, and so that's where that weight is coming from. There's 8 protons. This tells me that there are really close to 8 neutrons as well. That gives me that 16 atomic mass, okay? But I can actually have a different number of neutrons. I don't have to have an equal number of neutrons. You can have an oxygen with 7 neutrons or 9 neutrons. They can differ, and they don't change the properties that much, okay? The mass number, which is not on this square, it's not typically on a periodic table, is the number that tells you the number of the isotope, okay? So for instance, carbon 12, that's not the atomic number. The atomic number of carbon is 6, but carbon 12 tells us that there are 6 protons and 6 neutrons. If I had carbon 13, still 6 protons, but now there's going to be 7 neutrons. Okay, and so on and so on. So that mass number identifies the isotope, and it allows you to figure out how many neutrons there actually are. Well, the more neutrons there are, the heavier the atom is going to be. So we have this atomic mass, which is actually the average of the common isotopes of an element. You know, certain isotopes occur more frequently, and so that's taken into account for the measurement of that atomic mass, okay? Now let's talk about ions. Ions are charged particles, they're charged atoms, meaning they don't have an equal number of electrons and protons. If they are equal, it's not charged and it's not considered an ion, okay? Now we have two different types of ions. We have cations and anions. With a cation, what happened is the atom has lost its electrons. We'll talk about why that happens. It has to do with like chemical reactions and chemical bondings. But sometimes the electrons actually leave. So that negative number goes away, leaving you with a higher number of positive protons. And so a cation is positively charged. The reverse can also happen. An atom can actually gain electrons from something else. It's still the same atom. It gains some of those negative electrons, giving it a negative charge, and that's called an anion. Okay, so make sure you get that vocab down. And I believe that is all. Hopefully your mind is not too blown. I will see you guys later.